Students, welcome back to the class. My today's lecture is angular momentum. Rajesh sir, senior lecturer physics, has sent you the notes of this topic, but I am going to discuss with you in detail this topic. So let me start angular momentum. So what is angular momentum? All of you know that when a body has linear motion, then linear momentum is associated with it. क्लियर व्हेन ए बॉडी हैज़ लीनियर मोशन में बॉडी जो है उसके साथ क्या एसोशिएट होता है द लीनियर मोमेंटम इज एसोशिएटेड विद इट बट व्हेन ए बॉडी हैज़ रोटेशनल मोशन ओके व्हेन द बॉडी हैज़ रोटेशनल मोशन then angular momentum is associated with it. In linear motion linear momentum is associated, but in angular motion in rotational motion angular momentum is associated with it. Okay, linear motion, in linear motion linear momentum is associated, but in rotational motion angular momentum is associated with it. Angular momentum is associated with it. Okay, associated with it. Clear? So let us define angular momentum. Clear? What is an angular momentum? The angular momentum of a body about an axis of rotation. It belongs to rotational motion. So we will take angular momentum of body about an axis of rotation. About an axis of rotation is defined as the product of linear momentum and the perpendicular distance. परपेंडिकुलर डिस्टेंस किसके बीच का परपेंडिकुलर डिस्टेंस? बिटवीन लाइन ऑफ एक्शन ऑफ लीनियर मोमेंटम and axis of rotation it is denoted by angular momentum is denoted by capital L. Clear? What is an angular momentum? Angular momentum about an axis of rotation is defined as the product of linear momentum. किसका प्रोडक्ट है? लीनियर मोमेंटम का and the perpendicular distance between the line of action of momentum and the axis of rotation. But in case of torque, हम लेते थे we take distance product of the perpendicular distance and the movement and the force. ठीक है, force का लेते थे ना, that is line of action of force. But what was their line of action of force? But we take here line of action of linear momentum. So we can say torque was moment of force. We call it either torque or moment of force. But similarly angular momentum is either angular momentum or moment of momentum So see here, what will be the angular momentum? In mathematical form, angular momentum is equal to linear momentum as per definition. Linear momentum into perpendicular distance into perpendicular distance. So angular momentum is denoted by capital L, and linear momentum, we take linear momentum is we can take perpendicular distance is r and linear momentum is p. Clear? Linear momentum is denoted by p. All of you know linear momentum is denoted by p. So let L is equal to r into what is p? What is p? P is equal to product of mass and velocity. Okay? What is the definition of the linear momentum? It is defined as the product of mass and velocity. So here we can write mv. L is equal to r into, this is m is constant. Okay? M is constant, so we can write down here r cross v. Here is m and this is r and this is cross vector v. And this is cross product, so we can write down it as m b r sine of theta. M r v sine of theta. L is m r v sine of theta. This is the value of angular momentum. Clear? Now what is its unit? Unit of angular momentum. Unit of angular momentum. What will be the unit of angular momentum? See here, r is in meter into, what is p? P is mass into velocity. Mass is kg, velocity is meter per second. Clear? So there meter square kg per second. Meter square kg, kg, इसे लिख लो आप, किलोग्राम मीटर स्क्वायर पर सेकेंड. Kilogram meter square per second. This is the unit of angular momentum. Clear to all of you? Now I will explain with you the angular momentum in Cartesian coordinates. Angular momentum in Cartesian coordinates. We can say angular momentum as moment of momentum. What is this? Another name? Moment of momentum. Like the name of torque is moment of force, but its another name is moment of momentum. Clear? So now we will explain angular momentum in Cartesian coordinate. Clear? According to Newton's second law of motion. According to Newton's second law of motion, in translational motion, this is translational motion. In translational motion, force is defined as the rate of change of linear momentum. All of you know very clearly in Newton's second law of motion, what is its statement? That is the rate of change of linear momentum of the linear force is defined as the rate of change of linear momentum of the body. What in rotational motion? We are talking about rotational motion. What in rotational motion? Torque is defined as. Torque is defined as the rate of change of angular momentum. Rate of change of angular momentum. All of you must keep in mind that in case angular momentum of the body. According to Newton's second law of motion, force is defined as the rate of change of linear momentum of the body. Clear? But in rotational motion, what is the definition of the torque? Torque is defined as the rate of change of angular momentum. Force is defined as the rate of change of linear momentum, but torque is defined as the rate of change of angular momentum of the body. That is, torque is denoted by tau. Clear? But how can we write rate of change of linear momentum, force is rate of change of linear momentum, that is dp upon dt. This is the way of writing in differentiation form, rate of change of linear momentum. Clear? Similarly, we can write down here rate of change of angular momentum. How we will write? Rate of change of angular momentum मतलब dl upon dt. ठीक है? In the similar way, dp upon dt is the rate of change of linear momentum, but dl upon dt is the rate of change of angular momentum, that is called as torque. Clear? Now, what is its expression? Let px and py be the linear momentum of the body along x direction and y direction respectively. Okay, where px is, what is px? mvx, mass into velocity. This is along x-axis, and py will be mvy, mass into velocity, it is along y-axis. From the expression of torque, what was the expression of torque? The expression of torque was tau is equal to x. Last time we did this expression in Cartesian coordinates, x fy minus y fx. You can consult from that topic. The expression of torque was x fy minus y fx. मैंने वहीं से ये एक्सप्रेशन उठाई है और यहाँ पर राइट डाउन की है. ठीक है. Now, according to Newton's second law of motion, what will be fx is d upon dt px. This is second, and similarly fy is equal to d upon dt, and here will be py. Clear? Now put second in third. This is third. Put second and third in first. We get, this is first, tau is, what will be here? X. What is fy is d upon dt. This is py. Clear? Here is sign of minus. This tau is equal to x fy minus y fx. This is x. What is the value of fy? D upon dt into py. This is dpy upon dt. This is dpy upon dt. Minus, this is y. This is y. What is fx? dpx upon dt. Clear? We use equation second and third in equation first. Then what will we get? D upon dt. We can write down it as d upon dt. X py minus y px. We can write down it d upon dt x py minus y px. So we know that हम इसको इस ढंग से भी राइट डाउन कर सकते हैं. d upon dt, this is x py minus y px. So tau upon is equal to d upon dt. What is the, whose value is this? This is x py minus y px. What will be this? This will be d upon dt into, this is the value of L. This is the value of L. This will be, this is equation 4th and this is equation 5. Now comparing 4th and 5th, we have, comparing 4th and 5th, we have 4th and 5th. L is equal to x py minus y px. This is the expression for angular momentum in Cartesian